Hi guys, this is Virendra from iDeserve. Today I'm going to talk about longest palindromic substring. So given a string like bananas, we want to find out the longest palindromic substring here. So you have ANA, NAN as palindromes here. You also have ANA, NA, which is the longest palindrome. We want to find this out. So there is a brute force solution to this where we check all the substrings of length 1 to n and then test each of the substring to be a palindrome or not. So that amounts to order of n cube, which is very inefficient. There are three more efficient solutions to this problem, of which I am going to discuss one based on dynamic programming. Before going there, let's try to understand how to detect a palindrome given a string like this. First, we would compare the first and the last characters. If the first and the last characters match, then we would go ahead and see if the remaining substring after stripping out the first and the last character is a palindrome or not. If the remaining substring is also a palindrome, then the whole string is a palindrome. That are the two conditions that we want to leverage in the dynamic programming approach. So in this approach, we have a table like this where the string is represented as rows and column both. We also keep track of the current length that we are looking at. So we will be going from substring of length 1 to n, and we'll keep track of what length that we are at using this variable current length. We'll also use another variable called maximum length, which will keep track of the maximum length of the longest palindrome that we have at that point here. And then we'll also store the longest palindrome we have encountered along the way. So let's start with substrings of length 1, which are trivially palindrome. Those will update as true, right? Let's go to lengths of 2. Here B and A do not match, right? So it doesn't satisfy our first condition, so it's not a palindrome. AN is also not a palindrome, so we say false here. And then NA is not a palindrome, again AN is not a palindrome, and so on. Let's go to length of 3. What we see is B and N do not match, so false again. But here A and A is a palindrome because A and A matches, and if we strip out A and A, N is already a palindrome here, so we update true here. We also find NAN as a palindrome similarly. Again ANA is a palindrome similarly, right? So let's go to the length 4. For length 4 we don't find any palindromes. For length 5 we find a bigger palindrome where A and A matches. NAN we already know is a palindrome, so both the conditions are true, so we update true here. Finally, the length 6. For length 6, the first and the last characters do not match, so we have to update false. The longest palindrome that we found here is ANA. So let's look at the code. This part is initialization, where we keep track of the index where the longest palindrome begins. We also keep track of length of the longest palindrome, and we also have a boolean table to store the palindrome truth values. So these are the palindrome truth values. The first loop is to update all the single letter palindromes, which is here. And second loop is to update all 2 character palindromes, which is basically this diagram, right? BA, AN, NA, and so on. And the third loop is to go from length 3 to n and save the longest palindrome that we find, right? So the 2 conditions that I mentioned are here. The first one is to check if the first and the last characters match, and the second is to see if the rest of the substring is a palindrome. So if we are at here A and A, we are looking at a length 3 substring. What we are going to do is see first and the last character. If they match, the first condition satisfies, and then strip off the first and the last character, which is basically I plus 1 j minus 1. We are looking at N, right? N is already a palindrome. So both the conditions satisfy, so we'll be updating this particular cell of this table as true. We go on till length n and we find ANA similarly with this procedure, and finally we can take the substring of the original string using both the variables that we keep track of, the index where the palindrome starts and the maximum length of the palindrome using here. Also, the time and space complexity of this particular algorithm is order of n squared. Please go through the code which is below this video. Also look at the visualization. Please let me know if you have any questions and concerns. Thank you.